This is question 10c from the 2018 Chemistry Leaving Certificate Higher Level paper. It's a stoichiometry question. So stoichiometry focuses around this. This is the main formula to be using: n representing number of moles equals mass over relative molecular mass. Okay, so I'm going to be using this formula, and I'm going to use the chemical equation and create a table based on these three variables in that formula. So first thing I'll do is I'll write out the chemical equation. And now once I've got the chemical equation written out, I will make this table that I mentioned. So I've got, in the first row I'll have mass, and then I'll have relative molecular mass, and then I'll have numbers of moles. Okay, what information are we given? This is the key bit of information for starting us off. The iron phosphate formed was found to have a mass of 4.53 grams. Okay, so we feed this information into our table, and so this is the substance we're interested in there, iron phosphate. So we'll feed that information in. We've got the mass, so it's 4.53 grams. Okay, so we want to establish the number of moles, because the first part of the question is how many moles of iron were removed from the object in the rust treatment process. So we're looking for the numbers of moles of iron. So we've got to find out how many moles of iron are in this mass of iron phosphate. So now we're going to work on this part. Okay, we're going to feed in or fill in the relative molecular mass of iron phosphate. So iron phosphate is FePO4, so we want to get the relative molecular mass of that. So we add up the relative atomic masses of the atoms present in that molecule. Okay, and add them up. In a calculator we get 151 grams in 1 mole of this substance. So you can just, it's useful to say there's 151 grams per mole. So 151 grams per mole. And now that we've got, of this formula, now that we've got mass, and now we've got relative molecular mass, we can calculate the numbers of moles. So we've got 4.53 grams divided by 151 grams per mole, the relative molecular mass, and put that into a calculator, and we find that equals 0.03 moles. So we put that into our table, 0.03 moles. And that's our answer for the numbers of moles of iron. Okay, it's 1 mole of iron in 1 mole of iron phosphate. Next question, we're looking at part 2. What mass of rust was adhering to the object before the treatment? So we're told rust is Fe2O3, so it's this molecule that we're interested in. So now that we know the number of moles of iron phosphate, we can, relative to all the other substances in this chemical equation, we can work out the moles. So we can see that there's a coefficient of 2 here, and there's nothing here, so by convention that's 1. So what we've got is a 1 to 2 ratio. So we'd have half the numbers of moles of rust, iron oxide, as we would of iron phosphate. So we'll have 0.015 moles of rust. And now let's work out the relative molecular mass, and that will allow us to get the number, to get us the mass of rust. So using this formula again, we've got numbers of moles equals mass. Okay, we don't have the mass. oh, sorry, yeah, we've got the numbers of moles, so we'll fill in this value, and we need to calculate the relative molecular mass. So let's do that now. So the relative molecular mass of iron oxide, well, we're looking at iron, so 56.2 plus oxygen, oops, 16/3, and that equals 160 grams per mole. Okay, so that's the relative molecular mass of it. So we can plug in our values. Moles is 0.0151 moles equals mass over relative molecular mass. And now to get the numbers of, or to get the mass, we'll multiply both sides by 160. And they cancel there. So 160 by 0.015 equals 2.4 grams. So I can feed that into my table. I've got 160 grams per mole, and I've got 2.4 grams. So that's my answer for part 2, 2.4 grams. Now I'm looking at part 3. What is the minimum volume in centimeters cubed of a 6 molar solution of phosphoric acid needed to remove all the rust? Okay, so first thing is to calculate the numbers of moles based on this equation and the mole values that we've already established. So it's a 1-to-1 ratio here, so it'll equal 0.03 moles of phosphoric acid. So we need 0.03 moles of phosphoric acid, and we know that in a 6 molar solution, we've got 6 moles in 1,000 centimeters cubed. So 1 mole equals 1,000. So I'm just dividing both sides by 6. And now to find out how many centimeters cubed in 0.3 moles, multiply that fraction by 0.03. And plug that into the calculator and we get 5 centimeters cubed. Okay, so that's my answer for part 3. 5 centimeters cubed of 6 molar phosphoric acid. Part 4, what volume of liquid water, and we're given the density, was produced in this reaction? Let's get the numbers of moles of water. Okay, so what goes in here? It's a 1-to-3 reaction with rust. So I'm looking at the 3 coefficient here, and nothing before rust, the iron oxide. So by convention, that's a 1. So it's a 1-to-3 reaction. So 3 times numbers of moles of water as we would of rust. So it's 0.045 moles. And now let's work out the mass, and then we can get to the volume. So the relative molecular mass of water is 18 grams per mole. Okay, so that's simply We've got hydrogen, so 1 gram per mole. And we've got 2 of those, plus 16 for oxygen, so that gives 18 grams per mole. So there we are there. And now to get the mass, using this formula again, we've got relative molecular mass and the numbers of moles here in our table, so we can multiply them together and we get 0.81 grams. Okay, so that was 18 grams per mole by 0.045 moles. Multiply that together and get 0.81 grams. And now we know the mass. I suppose we're looking at the density formula because we're given density. I know that density equals volume over mass. And we've got the mass and we've got the density. The density is it's 1.0 grams per centimeter cubed equals volume, and over mass we got 0.81 grams. And to isolate the volume, we're going to multiply both sides by 0.81 grams. That cancels there, and we got 0.81 grams here, multiplying by that value. And 1 by 0.81 equals 0.81 centimeters cubed as the volume. So that's our answer for the last part.